Good morning, dear students. Welcome to Jatin's Academy. So today in this class we are going to start with the second chapter of physics, class 8 ICSE, that is physical quantities and measurement. So in this class we are going to start first of all with the density and its units. Then we are having determination of density of solid. Then we are having density of regular as well as irregular solids. Next we are having determination of density of liquids by the use of density bottle. Next we are having relative density and its units. Then we are having variation in density of an object due to its temperature. Then we are having principle of flotation. Then we are going to study about applications of flotation. So first topic we are having physical quantities. As the chapter name suggests, physical quantities and measurement. So first of all we should know that what are physical quantities. So what are physical quantities? The quantities that can be measured are known as physical quantities. Whatsoever quantities are present in our surrounding, for example mass. If I want to measure the mass of these apples, so can I measure this mass of apple? Then yes, obviously yes, with the help of beam balance. So I want to measure the length of this person. So can I measure the length of this person? Then yes, by using some instrument I will measure. Fine. So whatsoever quantities which we can measure easily are known as physical quantities. For example, mass, length, time, temperature, speed, acceleration. These all quantities that we can measure are known as physical quantities, and the process by which we are measuring these kind of physical quantities, that process is known as measurement. Clear the name of the chapter, physical quantities and measurement. So in this chapter mainly we are going to discuss about the two things. First we are having density, then we are having relative density. So let us start with the main topic of this chapter, that is density. So what do you mean by density? Density means the mass of an object contained in a matter per unit volume. What does it mean? It means that how much particles of matter are contained per unit volume, that is known as its density. This is a density. Density means mass contained in any per unit volume, that is known as its density. For example, here I am having solid A and solid B. In solid A, you can check in solid A and B, both are having same volume. It is also having volume V, it is also having volume V. Means same volume they are having. I will compare here densities. Okay. So here you can see particles or particles of matter is less in A as compared to B. Here mass per unit volume is less, no? Here particles are less in A, but here mass of an object contained in volume is more because here particles are more. If here mass is less, means here density is also less. Mass is less per unit volume means density is also less. And here you can see in B solid, here particles per unit volume is more, means mass is more. Here means density is also more. Why? Because density is going to depend upon two factors. First, it is going to depend upon mass. More will be the mass, more will be the density. And second, it is going to depend upon volume. It is inversely proportional to volume. More is the volume of any body, less is the density, and less is the volume of any body, more is the density. In the further slides, I am going to teach all the things. Fine. So here we are having just the definition. Next we are having density of different matter. As we know, three states of matter are there. First we are having solids, then we are having liquids, then we are having gases. So one by one we will discuss about density in solid, density in liquid as well as density in gas. So here we are having the arrangement of solids. As you know that in solids particles are very tightly packed and very less intermolecular space is there. Fine. Or you can say force of attraction between the particle is more. So here you can see if I am taking the volume as V, so here particles per unit volume is more. If particles are more means mass is more. So density of solid as compared to liquid and gases is more. Why? Because per unit volume mass is more. Mass is more per unit volume, that is why here density is more. If I talk about liquids, in liquid you can say that in fixed volume, same in this volume V, same in this volume V. But in this volume V, particles per unit volume is less, na? If particles per unit volume is less, means mass is less. If mass is less, means density as compared to solid is less. Similarly, if I talk about in gases particles are very far apart from each other. In a same volume V, in same volume this V, in same space you can say volume, you can say space also. So here you can see particles contained per unit volume is very much less. If particle is very much less means mass is also very much less. If mass is less means density is also less. So here you can compare like this the density of three states of matter like solid, liquid and gases. Next, we are having formula for measuring density. As I already told that density is going to depend upon two factors, that is mass and volume. First of all, density we are going to represent by this letter rho. This is the way how we are going to represent the density. So density is going to depend upon two factors. Firstly, density is directly proportional to mass of any particle, mass of any substance, over it is inversely proportional to the volume. This is a formula of the density. See the formula, density is equals to mass over volume. Means density is directly proportional to mass and density is inversely proportional to volume. So here we are having the units of density. As we have already discussed the formula of density, that density is equal to mass per unit volume. Fine, this formula we are having. Now we are going to calculate the SI unit of density. In order to calculate the SI unit of density, first of all we should know SI unit of mass. Then afterwards we should know SI unit of volume. So what is the SI unit of mass? SI unit of mass is kg or kilogram. And what about SI unit of volume? SI unit of volume is cubic meter, or you can write like this also, meter cube. Okay, now just put in this formula. Density is equal to mass over volume. SI unit of mass is kilogram. SI unit of mass is kilogram over SI unit of volume is meter cube. So what is the SI unit of density? SI unit of density is kilogram per meter cube. So here is the SI unit of density, kilogram per cubic meter or meter cube you can write. Fine. So if we are having very small sized object, if I am having very small size object and for this object I want to calculate the density, so here units should be also small. So how I am going to use the smaller units? So here mass I am going to measure in grams instead of kilogram. I am using here gram, and here volume I am going to express in centimeter cube. Instead of meter cube, here volume I am going to use in centimeter cube. So what is a unit of density? So as we know, density is equals to mass over volume. So here mass I am taking in gram, volume I am taking in centimeter cube. The smaller unit is gram per centimeter cube. And this unit of density is nothing but a CGS unit of density. So what is the SI unit of density? SI unit is kilogram per meter cube and CGS unit of density is gram per centimeter cube, which is very important from exam point of view also. These two units you have to remember properly. Fine. Next, we are having relation between SI and CGS unit of density. This question is also very important from exam point of view. So first of all, what is the SI unit of density? As we know, SI unit of density is kilogram per meter cube. And what is the CGS unit? CGS unit of density is gram per centimeter cube. Here we are going to express the relation between kilogram per meter cube and gram per centimeter cube. Firstly, can I take this kilogram per meter cube as 1 kilogram by 1 meter cube? Because here I am going to just talk about 1 kilogram per meter cube of density. Okay, in order to make the comparison between SI and CGS unit, I will take for only 1 kg, 1 kilogram per meter cube. So here in 1 kilogram, can you tell me in 1 kilogram how many gram are there? So yes, in 1 kilogram, 1000 grams are there. So it is 1000 gram over. What about meter and centimeter? So in 1 meter cube, how many centimeter cube are there? So as in 1 meter, 100 centimeter are there. But here I am not talking about simple meter and simple centimeter. Here I am having meter cube, centimeter cube. So in 1 meter cube, 100 multiply 100 multiply 100. This much kind of centimeter cube we are having. So what does it mean? 100 multiply 100 multiply 100 centimeter cube. Clear? So now we have to solve the mathematic problem. 1, 2, 3, 1, 2, 3. So here you will get 1 kilogram by 1 meter cube is equals to 1 gram over. Here you will get 1000 centimeter cube. Now write it properly. 1 kilogram per meter cube is equals to 1 by 1000 gram per centimeter cube. So this is a relation between SI unit of density, this is SI unit of density, and this is CGS unit of density. Here we are having the relation 1 kilogram per meter cube is equals to 1 by 1000 gram per centimeter cube. If I want to see like this, like 1 gram per centimeter cube is how many kilogram per meter cube? So if I am having here 1000 in divide, to that side it will go in multiply. Okay, so here it will go in multiply. So here we are having 1 gram per centimeter cube is equals to 1000 kilogram per meter cube. This is a relation between SI and CGS unit of density. Next we are having numerical problem related to density. So first numerical we are having a cuboid of iron has dimensions this. So here we are having the dimension 6 centimeter, 4 centimeter and 3 centimeter. Means from these dimensions we will calculate the volume. Afterwards what we are having, firstly we will write the volume. Volume we are given with 6 centimeter, multiply 4 centimeter, multiply we are having 3 centimeter. Fine. So first of all we will calculate this. So 6 into 4 into 3 will give you 72 centimeter cube. Afterwards we are having, if the iron cuboid weighs 560 gram. Weighs means gram means here we are having mass. So mass is given 560 gram. Find the density of iron we have to calculate. So what is the density of iron, or what is the formula for density? As we know, density is equals to mass over volume. So mass here we are given with 560 gram. Over volume we are given with 72. Here please check carefully, if the volume is in centimeter, mass is in gram, then it's okay. In gram per centimeter cube in CGS we will calculate the density, fine. But here if in this case mass will be in kg and volume will be in centimeter cube, then we have to check properly, we have to convert the units. Either we should calculate the density in gram per centimeter cube or CGS unit, or you can calculate the density in SI unit or kilogram per meter cube. So here we are given properly, no need to change. So just 560 we are going to divide with 72. Here you will get 7.7 gram per centimeter cube as the density of the iron. So like this way you can calculate easily the density of any object by using its mass and by using its volume. Next we are having second example. 1 liter pack of cooking oil. 1 liter means here we are given with volume. So volume is 1 liter. Weighs 920 gram. So here mass is also given 920 gram. Calculate the density of cooking oil. Density of cooking oil I have to calculate. Express your answer in kilogram per cubic meter. Means I have to calculate the density in kilogram per meter cube. Okay. So first of all I have to convert this 1 liter into meter cube. So this relation you have to learn. 1 liter is equals to 10 to the raised power minus 3 meter cube. This relation you have to remember. Okay. 1 liter is nothing but a 10 to the raised power minus 3 meter cube. And in 1 gram, how many kilogram are there? 10 to the raised power minus 3 kilogram are there. Fine. As we know, in 1 kilogram, 1000 gram are there. Okay, if I want here 1, so 1000 I will take that side. So it will be 1 by 1000 kilogram is equals to 1 gram. 1000 means what? 10 to the raised power 3 kg is equals to 1 gram, and 10 to the power 3 downside is in positive, upside it will go in negative. Or simply like this you can remember, 1 gram is equals to 10 to the raised power minus 3 kilogram. So just convert it. We are having volume here 1 liter. 1 liter convert into meter cube, that is 10 to the raised power minus 3 meter cube. And mass also we have to convert. Mass is 920 multiply 10 to the raised power minus 3 kilogram. So density we have to calculate. Density formula is what? Density is mass by volume. Just put here the values. Density is equals to mass. Mass is what? 920 into 10 to the raised power minus 3 kilogram. Over volume is what? Volume is 10 to the raised power minus 3 meter cube. So 10 to the raised power minus 3, 10 to the raised power minus 3 we are going to cancel. So density we got it as 920 kilogram per meter cube. Like this you can calculate the density in kilogram per meter cube. But yes, these two expressions you have to learn. These two relations you have to learn properly. Fine. Next we are having third numerical related to density. A metal sphere of radius 2.5. This kind of metal sphere I am having, which is having radius 2.5 centimeter, and mass of this metal sphere is given as 540 gram. Okay, mass is given and radius is given. We have to calculate the density. Density we have to calculate. As we know, in density we have to check out mass as well as volume. So here mass is given, fine, but my main problem is about the volume. So what is the volume of sphere? So here you have to remember the formula for volume of sphere. Volume of sphere is equals to 4 by 3 pi r cube. This formula is there for volume of sphere. So just put the value of radius here. It will be 4 by 3. Pi means 22 by 7 and radius here we are having 2.5 cube. When you will solve all this relation, you will get 4 multiply 22 multiply 2.5 into 2.5 to 2.5. Here you will get 1375 by 21 because 7 3s are 21. When you will divide it, you will get 65.47. So it will be the volume of sphere, 65.47. So volume we given, mass is there. So now we are going to calculate the density. But here you have to calculate density in SI unit. Firstly, I will convert like this only, gram per centimeter cube. Afterwards, I will multiply it with 1000. Fine. So see carefully, density we know, mass over volume. So what is the mass? Mass we are given with 540 gram. Over volume we are given with 65.47. Now here your math works. Math you have to do. So what you have to do? You have to divide just 540 with 65.47. So what you will get? You will get density as 8.24 gram per centimeter cube. This value came in gram per centimeter cube, but our question is you have to express the answer in SI unit. Whenever you are given with gram per centimeter cube and you have to convert that density in kilogram per meter cube, then simply multiply this numeric value with 1000. Okay, simply multiply it with 1000, and same for the reverse. If I am having here I will write kilogram per meter cube, I have to convert in gram per centimeter cube, then that numeric value you have to divide by 1000. This relation you can learn, it will be very helpful for you. Okay, so gram per centimeter cube you have to convert in kilogram because question is there for the SI unit. So just multiply it with 1000. 8.24 multiply 1000 kilogram per meter cube. So when you will multiply it with 1000, what you will get? You will get it as 8248, approximately 8248 kilogram per meter cube as the density of sphere. Like this you have to solve the numerical. Next we are having determination of density of solid. As we know, solids are of two types. Either it will be a regular solid or either it will be a irregular solid. For the regular solid, it is very easy to find the density. How? I will tell you. As we know, density is equals to mass by volume, and I want to measure, for example, density of this cube. This is a regular solid cube. How I will measure the mass? Simply by using the beam balance. I will take the beam balance and I will measure the mass of this cube easily. Fine. Afterwards, problem is for the volume. So how I will find the volume of this cube? I will just make the formula. I will just use the formula. Formula of cube is, or volume of cube is, a cube or side cube. I will use the formula of volume of plane figure. Then I will just put in the value of density is equals to mass over volume, and I will find the density. But the problem is for irregular solid, because for the irregular solid, irregular solid you can easily find the mass by using beam balance. That is okay, that is not a problem. Problem is with volume, that how you will find the volume of this irregular shape object, because for irregular shape object no appropriate formulas are there. So now I am going to discuss with you that how we are going to measure the volume of irregular solids. Now see carefully. So here we are having the regular solid and here we are having irregular shaped object. Next we are having density of regular object, that I already discussed with you. The density of regular solid you are going to measure by using mass and volume. So mass you will measure easily by using this kind of beam balance, and volume you can easily measure by using formula. But our main problem is to find the density of irregular solid. How to measure the density of irregular solid? See carefully. First method here I am having by using a measuring cylinder. This is a measuring cylinder. So what you will do? First of all, we will take a measuring cylinder in which proper readings will be there. For example, this water is filled up to 50 ml. For example, this water in the measuring cylinder is filled up to 50 ml. And here I want to measure the volume of this irregular shaped. object, because volume I can't measure na, of this stone. If I want to measure the density of this stone, then mass of this stone to I will find easily with the help of beam balance. It is not an issue, but the issue is with the volume. So volume I can find with this measuring cylinder. How I will find? Just you have to take the irregular solid, you have to tie it with the string, then that irregular solid you have to put inside the measuring cylinder. When you will put inside the measuring cylinder, the volume of the water will rise. For example, firstly it is 50 ml, then it goes to 60 ml, for example. Okay, so now you have to calculate the difference in both. Here it is 60 ml minus 50 ml. Whatsoever difference will come, for example 10 ml, so means the volume of this solid is nothing but 10 ml. Fine. Whatsoever water is displaced by this irregular solid, that much displaced water is the volume of this solid. Clear my point? If this water is displacing 10 ml of water and water level is coming up, means it is coming to 60 ml, so it is displacing 10 ml of water. So this 10 ml of is nothing but the volume of this irregular solid. So by this way, by using a measuring cylinder, you can easily find the volume of any irregular solid. Next we are having, in order to find the volume of any irregular solid, we are using a Eureka Can. This is a Eureka Can. In the Eureka Can, what we are having? In the Eureka Can, firstly we are having a spout at one end. In the Eureka Can, here we are having spout at one end, and this Eureka Can we are going to fill till this spout. Till this spout we are going to fill this Eureka Can. Then afterwards what we have to do? Whatsoever irregular solids volume you have to calculate, that irregular solid you will tie with the string. Then afterwards gently you have to put into the Eureka Can. Whatsoever water is going to displace from this Eureka Can and moves into this measuring cylinder, that volume of water you have to measure. For example, now this volume of measure came it as, this volume of volume of water is came it as, for example 10 ml. For example, here volume came out 10 ml. So 10 ml is nothing but the volume of this irregular shaped object. Means here you have to check that how much water came out after putting this irregular solid into the Eureka Can. This whatsoever amount of water came out, that amount of water is nothing but the volume of this irregular shaped object. So volume you can measure easily by Eureka Can, and mass you can measure by using the beam balance. So by using the formula density is equal to mass over volume, you can easily find the density of irregular shaped object. Next we are having determination of density of liquid. Till far we have discussed that how we are going to measure the density of regular solid as well as density of irregular solid. But now we are going to discuss here about the density of liquid. So in order to measure the density of liquid, one main or accurate method we are having of the density bottle. This is a density bottle. Density bottle is actually a specially designed bottle which is used to determine the density of liquid. In this density bottle, here we are having a glass topper, and in the glass topper here we are having a capillary tube. So what is the function of this glass topper and capillary tube? I am going to discuss it with you also. So in this density bottle you are going to fill the water till this properly. You are going to, with the till the neck, you are going to fill the water into the density bottle. Actually density bottle came with the appropriate volume. For example, 25 ml density bottle is there, 50 ml density bottle is there, or any other readings of density bottle are also there. Fine. So this exact volume of density bottle is there. Means in this, for example, this is 25 ml density bottle. Means in this 25 ml density bottle, exact 25 ml of liquid only we are going to put. If we will put extra volume into it, or we will put extra liquid into it, then that extra liquid will come out from this capillary tube. Action of this capillary tube is what? Use of this capillary tube is what? It will take all the extra liquid from the density bottle and it will throw out. Means in this density bottle only exact volume of liquid we can pour. Fine. Then afterwards, from this density bottle we can easily see that yes, 25 ml of liquid we have put. Means for the formula density is equals to mass over volume problem solved. Why? Because we know that in this density bottle obviously 25 ml of liquid is there. That is not an issue. Afterwards we have to calculate the mass of this liquid. How to measure the mass of the liquid? This is a proper steps are there. That steps you have to follow. What are that steps? See carefully. First of all, you have to take this empty density bottle, and empty density bottle you have to measure here. Okay. For example, empty density bottle mass is M1. For example, empty density bottle, mass is m1. Afterward, you have to pour the liquid into it. For example, 25 ml liquid I have poured into it. Afterwards, I have to clean all the sides of this density bottle also, so that no extra mass will add here. When I will put the liquid into this of 25 ml, then I have to take the density bottle and I will put on the this electronic balance. On this electronic balance, I will put this density bottle and I will measure the mass. Now, for example, here mass came out as m2. For example, m2 mass came out filled with the liquid. Density bottle filled with liquid. Now, what is the mass of this liquid? For in order to measure the mass of this liquid, I will subtract both. I will do m2 minus m1. Means, first of all, with the filled bottle, whatsoever mass is there, for example, filled is 500 gram, mass is 500 gram, and empty mass is, for example, 10 gram, for example. Okay, so in order to measure the mass of this liquid, I will use the formula m2 minus m1 means 500 gram minus 10 gram means mass of the liquid is 490 gram. So like this way we will calculate mass also. Volume to we know only because density bottle is fixed volume. So that is why by this way we can easily use the density bottle in order to measure the density of any liquid. Now we are having numerical problem related to density. By this also you will see that how we are going to use the density bottle also. So empty beaker weighs 112 grams. So mass of empty beaker is given to us, that is 112 gram. When 100 ml of milk is poured into it, 100 ml of milk means volume of milk is given. So volume of milk is there 100 ml. The mass of the beaker changes to this. So mass of filled beaker. So now mass of filled beaker is 215 gram. Okay, empty is 112 gram but filled with liquid it is 215 gram. We have to calculate the density of milk. So density of milk means mass of milk over we have to check the volume of milk. Okay, mass of milk is what? Mass of milk means whatsoever it is after pouring the milk into that minus what is the original empty beaker. Okay, over we have to put the volume. So by using the subtraction formula, what you will get here, see carefully. Here you have to do subtraction. 215 minus 112. So here you will get 103 by 100. So you will get 1.03. So here you will get gram per centimeter cube or gram per milliliter you can say, because in 1 milliliter 1 centimeter cube are there. Fine, in 1 milliliter 1 centimeter cube only there. So it will be 100 centimeter cube. So density of this milk is 1.03 gram per centimeter cube. Next we are having the next topic of this chapter, that is this topic is also new for you, that is relative density. So what do you mean by relative density? See carefully. Relative density is defined as ratio of density of substance. It is a ratio of density of substance over density of water at 4 degrees Celsius. This formula we have to see. Actually, what is relative density? Relative density gives the comparison. Means if we are having the two objects and we want to compare that, for example, I am having two objects A and B. I want to compare that this object is heavier or this object is having more density or B object is having more density. In order to compare the density of A and B or in order to comparison of any two objects, we are using the word relative density. By using this formula, we can easily check out the comparison between the two objects, the densities of two objects. This is a relative density, density of substance over density of water at 4 degrees Celsius. This we have to take constant. Means at density of water at 4 degrees Celsius only we have to check the relative density. Why we are using 4 degrees Celsius only, that we are going to study in the next slide. So here we are having the formula, relative density is equals to density of substance over density of water at 4 degrees Celsius. So here we are having the question for you. Why do we consider density of water at 4 degrees Celsius only? Why we are using or defining the term like this? Relative density is equals to mass of density of substance over density of water at 4 degrees Celsius. What is the reason for this? See the answer carefully. The density of water changes with the change in temperature. Whenever we are giving the temperature to any solid or any liquid or any gas, the particles arrangement are going to change, means mass per unit volume is going to change. That is why density is also going to change. But density of water is 1000 kilogram per meter cube or 1 gram per centimeter cube only at 4 degrees Celsius. If I am talking about exact SI unit in exact units, so it will be 1 kilogram or 1 gram per centimeter cube and 1000 kilogram per meter cube as standard value at 4 degrees Celsius only. That is why we are taking the density of water at 4 degrees Celsius only. So next topic we are having units of relative density. As we know the formula of relative density, that relative density is equals to density of substance over density of water at 4 degrees Celsius. So here we are having the formula relative density. Relative density is equals to density of substance over density of water at 4 degrees Celsius. Okay, here you can see clearly that in both the ratios, in numerator and denominator, we are having the density. It is a ratio of both density. Whenever we are having the ratio of pure number, means upside also same quantity is there and downside also same quantity is there, then these both quantities are going to cancel out each other. So relative density is having no units. Why it is having no units? Because the relative density is a ratio of pure numbers. That is why relative density is unitless. So next we are having relation between relative density and density of substance. So as we know the formula for relative density is equals to density of substance over density of water at 4 degrees Celsius. We want the relation between relative density and this density of substance. It is very simple. Just take this density of water at 4 degrees Celsius, which is in divide form, to that side. It will go in multiply form. So what does we get? We will get density of substance is equals to this density of substance is equals to relative density of substance multiplied by density of water at 4 degrees Celsius. This is a relation between density of substance and relative density of substance. Okay, or density of substance with the density of water. Like this also you can learn. Fine. Next we are having, if we are considering the density of water at 4 degrees Celsius, so obviously at 4 degrees Celsius, here we are having density in SI unit 1000 kilogram per meter cube, and if we are talking about CGS unit, so at 4 degrees Celsius density is equals to 1 gram per centimeter cube. So here in this density of water at 4 degrees Celsius, I am going to put both the values. Firstly we are having density of substance is equals to relative density multiplied by density of water at 4 degrees Celsius. Either in first case I will put here 1000 kilogram per meter cube, like this also you can write, or you can write in the second way, density of the substance is equals to relative density multiply 1 gram per centimeter cube, because at 4 degrees Celsius density of water is either 1000 gram per kilogram per meter cube or it is 1 gram per centimeter cube. This relation also you can use in order to express the relation between density of substance and relative density. Fine. So here we are having the same density of substance is equals to relative density multiply 1000, or you can say relative density multiply by 1. So here we are having relative density multiply by 1 gram per centimeter cube, or like this you can write. Next topic we are having variation in density of an object due to the temperature. So as we know the formula of density is equals to mass over volume. Whenever we are giving temperature to any object, due to temperature mass of an object is not going to change at all, because as we know mass of the object is constant whenever we are moving from place to place, or either whenever we are giving heat to any object also, or we are going to cool that object, then also mass is not going to change at all. So what about volume? So volume, whenever we are giving the heat or whenever we are taking heat out of some substance, volume is going to change. So with this change in volume, density is also going to change. How does it happen? See carefully. For example, in this beaker, first of all, I am having this much volume of water. Fine. For example, mass of water is 5 gram. So mass of water with the giving or with the passing of the heat, mass of substance is not going to change. Here mass of substance will be same, that is 5 gram. But whenever we are giving heat to the liquid molecules, by gaining the heat, each and every substance is going to expand. Expand means volume is going to increase. Whenever by taking the heat volume increases, As you know, density and volume are inversely proportional. If volume increases, in that case density will decrease. But if in case I am taking heat out of water, or you can say I am going to cool the liquid, if I am going to cool the liquid, cooling means particles will come close to each other. If particles will come close to each other, means volume of an liquid is going to decrease. If volume is going to decrease, in that case density is inversely proportional, so in that case density is going to increase. So it all depends upon the volume. Whenever we are giving heat to any object, heat means expansion is there in the volume, expansion means density is going to less. But whenever we are taking heat out of body, or we are going to cool any substance, cooling means particles are going to come close to each other. Come to close means volume is going to reduce. If volume is reduced, obviously density will increase. So this is a relation between volume and density, how it is going to affect by temperature, like this it is going to affect. If I am talking about solid, in solid, as you know, particles are very close to each other. If particles are very close to each other, means whenever I am giving heat to these particles are not going to expand too much. Why? Because force of attraction between the particles is very much high. If force is high, then volume is also very much less, expansion will be there. So as we know, density is equals to mass by volume. Very less volume is expanded, means very less density is going to reduce. So in solid, very less expansion or very less decrease in the density is there. But if you talk about liquid, in a case of liquid, as I already told, that particles are away from each other. As compared to solid, particles are away from each other. Whenever we are giving heat to these particles, so these particles will move away from each other. Particles move away means volume increases. If volume increases, means here density is going to decrease. As compared to solid, density is going to decrease in a liquid whenever we are giving heat to that liquid. And if I am talking about gases, as you know, in gases particles are very far away from each other, and further if I am giving more and more heat to these gases particles, the particles are further moving away. Further moving away means volume is going to expand too much. If too much expansion is there in the volume, means density is going to reduce too much. So here maximum decrease in the density is going to seen in the gaseous as compared to solid and liquid. Next we are having floating and sinking process. In a case of floating and sinking, see carefully what we are going to see. Actually, whenever we are having a substance which is having density more as compared to this density of water or density of liquid, if this substance is having more density as compared to density of liquid, then that substance will sink in the liquid. See the definition here. When an object is placed over a liquid whose density is less than density of object, means this density of liquid is less. This density of liquid is less as compared to the object which we are going to immerse into it. So this object is having more density means it is the object is going to sink in the liquid. This is a sinking process. Fine. Next we are having flotation process. In the flotation process, if we are immersing the object into the water which is less denser than this water, if this footwear is having less density as compared to water, here water is having more density. Water is having more density means water is more denser than this footwear. So this footwear is going to float into the water. What does it mean? See carefully with definition. When an object is placed over the liquid whose density is more than density of object, means this liquid is having more density as compared to this object. In this object density is less, then that object will float in that liquid. Less is the density, flotation will be there. More is the density of substance, sinking process will be there. Fine. So next we are having principle of flotation, which is very important from exam point of view. What is the principle of flotation? See carefully. According to principle of flotation, a solid will sink in a liquid. When a solid will sink in a liquid, now might be you will give the answer. The solid will sink in a liquid if that solid is having more density as compared to liquid. Okay, but a solid will float on a liquid. Why the solid going to float on a liquid? Because if the solid is having less density as compared to density of liquid, then that solid will float in a liquid. Fine. So in terms of relative density, if we talk, then in terms of relative density, a solid will float on a liquid if its relative density of substance is less than relative density of water. If I am comparing relative density of substance and relative density of water, if the relative density of substance is less as compared to relative density of water, then that substance will float in water or float in liquid. But if the relative density of solid is more as compared to relative density of liquid, then that substance will sink or move downside to the liquid. Next, we are having applications of flotation. In the principle of flotation, we have learned that object will sink if it is having more density, and object will float if it is having less density as compared to liquid. Now, with the same principle, we are going to see some applications of flotation, that where these flotation we are going to see in our daily life. So first application we are having here, the density of ice is less than density of water. So actually density of water is at 4 degrees Celsius, that is 1000 kilogram per meter cube, or you can say 1 gram per centimeter cube. But the density of this iceberg, the density of this large mass of ice, it is less as compared to water. Why? Because you can see here the mass or the volume of this iceberg is too much high. If volume is too much high, we know the formula, density is equals to mass by volume. If volume is more, means density is less. So as compared to water, this iceberg is having less density. If iceberg is having less density, means that object will float in a water. That is why this iceberg is floating on a water. Next, we are having second application for the same flotation. Density of iron is more. Density of iron as compared to water is more. Density of iron is actually, iron density is 7800 kilogram per meter cube. These values you have to remember. Okay. And density of water at 4 degrees Celsius is, density of water at 4 degrees Celsius is 1000 kilogram per meter cube. So here you can check carefully that density of iron is more as compared to density of water. If density of iron is more, then obviously it is going to sink in a liquid. Okay, but why these kind of submarines or iron ships are going to float in a liquid? Why these iron ships are going to float in a liquid? See carefully. Actually, these iron ships are hollow from inside. The iron ship is having more volume. If it is having more volume, volume is more means density is less. Say it is a hollow from inside means volume of the iron ship is more. Volume of iron ship is more means density is less. So if density is less, then this iron ship is going to float on a water. Fine. Next application related to flotation we are having, submarine may float or sink on seawater. Actually this submarine is a watercraft which can move in water also and on water also. Means it can move inside water also, plus it can move on the surface of water also. Actually in submarine one water tank is there. Here in submarine one water tank is there, and which is called blast tank. This water tank is known as blast tank. When water tank or the blast tank is filled with water, when this water tank or blast tank is filled with water, the average density of the submarine increases. When average density increases, then water means it is going to sink into the water or move in the water. But when the water from this blast moves out from the tank, then average density of the submarine decreases. When average density decreases means one buoyant force is there, one upward force is there which acts on a submarine, and that's why submarines start coming out from the water and it start moving on the surface of the water. So by this way submarine may float or sink in the seawater. So submarine increase or decrease its effective density. Actually in class 8 you have to remember like this also only, that submarine can increase or decrease its effective density. How it increase or decrease its effective density? With the help of blast tank. So here is a spelling for blast tank. You can write BALLAST. This is a blast tank. So with this blast tank it can increase or decrease its effective density. Next application of flotation we are having, a fish has a bladder in her body. Actually in fishes also one kind of bladder is there. What they are doing, whenever they are sucking the air from the water into these bladders, whenever air is going to move inside their bladder, means volume of the bladder, you can say volume of the bladder is going to increase. For example, bladder is this much. Whenever they are going to fill it with the air, bladder volume is going to increase. And as we know, density is equals to mass by volume. If they are going to move inside, if the air is going to move inside the like bladder of the fish, means volume of the bladder is increases. Volume increases means density is going to decrease. If density decreases, in that case fish can float on seawater. But if I am saying the other side, that why fish are going to sink in a seawater, sinking means whenever whatever air is filled in her bladder, that air it push out to move in the water. When the air moves out, means volume is going to reduce. If volume reduces, we know density is equals to mass by volume. If volume reduces, means density is going to increase. So whenever density increase, it can easily sink in a seawater. So it is all depend upon the bladder. Whenever it is going to fill it with the air, the volume increases, density decreases, and whenever it is going to empty it from the air, means here volume decreases and density increases. So like this way fish can easily float or sink in a water. So when it forces the air out, when the fish is going to force the air out from the bladder, its average density is going to more and it can sink in a water. Why it is more? As I already told, if air is going to move outside, volume is going to reduce. Volume reduce means density is going to more. If density is more of an object as compared to water, it will sink in a water. Next application of flotation we are having in inverter batteries. Might be these kind of inverter batteries you have seen in your house. So in these inverter batteries, acid battery hydrometer is used. Why acid battery hydrometer? This is kind of hydrometer is used in order to check the density of acid solution, that how much denser this acid solution is there. In order to check that solution, we are using an instrument called hydrometer. Hydrometer also work on the principle of flotation. Okay, it can sink when it is having more density as compared to liquid, and it is going to float when it is having less density as compared to liquid. Next application we are having lactometer. So lactometer is also a kind of instrument which is used to measure the purity of milk. It also works on the principle of flotation of density. It is, if it is having more density, or if it is having more density, it is going to sink in a liquid, and if it is having less density, it is going to float in a liquid. So the purity of milk, or how it is denser or it is less denser, in order to check that, we are using the instrument called lactometer. Next application of flotation we are having, as the density of balloon filled with hydrogen gas. As we know, hydrogen and helium gas is having very much less mass. If less mass is there, as you know, density is equals to mass by volume. Mass of hydrogen and helium is less. If mass is less, means density is less. So if density is less, they can easily float in a air, because air is having more density as compared to hydrogen and helium. So whenever it is having less density as compared to air, so it may easily rise up and it will easily float in a air. So this is all about your chapter number 2, that is physical quantities and measurement of class 8th ICSE. If you like the explanation, please like it, share it and subscribe our YouTube channel. Thank you so much.